With this video, I'd like to go over the hands-on exercise dealing with time series. And first, we're going to import our modules. So we need both pandas and NumPy. So if we scroll down the notebook, let's read in the data first. And let's look at the first 5 rows. You see how we have a number of columns that with each column corresponding to a station with temperature, daily temperature. Now you see that this column here, which is unnamed, is the date, and we want to probably set the index with those timestamps. So we're going to do that directly into the read CSV function. So there's 2 components here. The first is setting the first column as the index column, and then also telling pandas that we do know that there are dates, so please parse them. And there we go. So we've got the timestamps as index. So let's first of all take a look at indexing and selection. So let's look at the index of average t, and you'll see what I was referring to before. We get a datetime index. So this is the data type, datetime 64. So it's refers to the double precision datetimes that are used as the index for this data frame. So let's use a string to select a specific row. So when by string we refer to the date. So what we can do is say let's pick March 22nd, and let's see if this works. Well, this doesn't work because remember that data frames by default will give us columns. So in order to be able to do the specific row, we can use the lock keyword, and there we go. So now we select this row with all the columns, and we get what we were looking for. So if we use a part of the string to select a specific month, here's the very nice thing about pandas. If this string can be parsed to anything that resembles a date, and there are some pre-formatted templates essentially that are used for dates, pandas will understand what we mean. So if we're looking for a specific month, we could just use the first 2 components of this. So let's again use the lock keyword, and let's grab February and all the columns, and you see we get 28 rows of data. So if we use the string syntax to select a range of dates, pandas allows us to use the familiar NumPy syntax that refers to slicing. So we can do the same thing by, for example, saying I want from January 1st all the way to January 5th. Now, here the only difference with NumPy slicing is that you will get the last index included into your selection. Versus, remember when we were using integer indices in NumPy, it was excluding the last one. So let's look at the function dateRange from pandas. And if we're going to create the same range, let's first of all look at, as always, let's look at the docstring. We have a start, we have an end, we have periods, frequency, and so forth. But we're going to focus on the start and end. And those again can take any arguments that resemble dates. So let's do this. That's the start. That's the end, and let's see what we get. Alright, so here you see how we can get, again, the same list of dates, a sequence of dates, same data type. Here's one interesting thing. The frequency here is day, D. So we'll see later on how we can switch that and get and play around with different frequencies in the dates. But let's do what the exercise asks us to do. So let's go to average t, location, and again we can use this date range. So let's just grab all the columns, and there we go, we got the same thing. So now if we wanted to get the first day of the week, let's try again pt date range, this time let's get more than 5 days just to make it more interesting. So let's get all the way to 131, so January 31st, and let's grab week. So again, there's a number of different keywords here. You can look up the pandas documentation. So you see now that we're picking from, by default it uses Sunday, so it finds the first Sunday of 2019 and starts there. So we can also do things like, I want you to start from Monday, and it will do that, or I want you to start from Friday. So now you see we're going a little bit before, so January 4th. So again, there's a number of different, well, BW is not one of those, but for example, B month is the business month, so you see we only get the end of the month. So again, look up the different keywords and you'll see, I think there's quite a few options there. Alright, so sometimes we want to lag our time series. If we use the shift, let's look at the shift function, docstring. Shift index by desired number of periods with an optional time frequency. So with here, if we do 1, you see that we shifted our time series into the future. So by 1 time step. Now this, if we just don't provide the frequency argument, then that means that whatever the time series is, if it's daily, hourly, it will just be shifted by 1. Now, what we can do though is we can say frequency, and let's shift by 1 week. So now you see that we start in January 6th, and it's using those values from January 1st. So frequency allows us to be more explicit, but if we don't care about that and we know that our time series is continuous, and we want to shift by, let's say, a day or a month, if it's monthly time series, then we can just use an integer input argument. But you can see if we're doing any sort of lag analysis, that shift function would be very, very useful. Alright, let's use the group by functionality to calculate the number of days that had a temperature less than 10 degrees and above 12. So let's take a look at that. So if we use the group by functionality, we are going to try to find the number of days. So first of all, we want to group by, we want to get 2 groups essentially, right? We want to get one group that's the number of days that has less than 10 and above 12. So with group by, remember that we can do things like we can group by a certain column, or we can provide it a sequence. In this case now, well, how do we get the number of days that are less than 10 and above 12? And of course, we can decide if we just want to do this for a specific station or for the average. So just to make things easier, let's do it for the average over all stations. So in order to get the average over all stations, remember that we can use the mean, and if we pass the axis keyword, then we are getting the time series, so across the columns. Whereas if we did without keywords axis 0, we get the mean of the entire time series for each station. So let's do this. Now, if we have to find temperatures that are less than 10 and above 12, we have to operate on this. So from this data structure, from this sequence, we will create a sequence that gives us a certain number or a certain value if everything belongs into this group or if everything belongs into that group. So why don't we create a function? And we can, well, first of all, let's see here. So if we do less than 10, see we get false and a bunch of truths, hopefully somewhere. Now, with this here, if it's less than 10, we want to make sure that it gets a group of 1. And if it's less than 12, we want to get, if it's above 12, we want to get, let's say, group 2. So in order to do that, we create a function, and we we will apply it there. But let's start here, and let's name it check temp. So t, if t is less than 10, then give us 1. Else if t is greater than 12, give us 2. We want to also capture the case where this doesn't happen, so let's return we have this, and then what we want to do is we want to apply, let's see, average t, and let's get the mean, x is 1, and what we want to do, we want to map, see if this will work, there we go. So we map this function to all the elements, there. Now, one thing we could do here is we can directly run group by, and we can get an error. So with this here, you see how we cannot use it directly on this, but what we can do is actually map again this, and we get the same index. So now if we go to group by on this entire sequence, there we go. So the reason it didn't work before is if we try to do the group by on this series here, it's not able to do anything because it tries to apply the function to the index. So if group by takes a function, it will apply it to the index and it will try to map that and then create the sequence. If we provide a sequence directly, and that's the reason why this works here, we provide the sequence directly, so it says, well, okay, you gave me a sequence that matches the index that I have, so now I know how to group everything. Alright, so now what we want to do is we want to apply a function to this object. So what we can do is apply the length function, and there we go. And turns out that all temperatures were above 12 in this case, so we only get only things that belong to group 90. So just to see that it actually works, let's do 25, and then let's do 28 here, there we go. So you see how we have some that are in between 25 and 28, and to answer this exact question, we would just have to remove this row here. But hopefully you see how we can write any kind of function, map it to the elements that we're interested in to create a sequence that will give us values that create distinctive groups. And with that, then we can apply any function we like. For example, we could say, oh, just give me the average. And you see how we get the average, but for each of these. So again, by having the same groups, we get the average. For each station. Alright, now using the group by functionality, calculate the average monthly temperature. So let's do that. First of all, what we need to do is we need to find a way to get the monthly average temperature. So we need to make sure that we get the month. So we need to create a sequence. Remember, if we map the function, map a function this time to the, remember the index. So we can map a function that takes t and provides the month. Let's see what happens. So remember that because they're datetime objects in each value of that index, we can manipulate them and get the year, the month, the day. We can add dates to them. So that's the benefit of having a time series object that Pandas understands. So here you can see that we're mapping a function. Here we're using an anonymous function. So for each element, we just grab the month. So this now creates the groups that we were looking for. So now if we do, let's see, average t, group by this sequence here, we get a group, and then we get the means. So now you see that these are the means for the temperature. These are the means for the temperature for each station for January, February, March. And if we wanted to get across, okay, this doesn't work. Let's try this. If we wanted to do, oh, I see. Okay, so we actually have to calculate the mean before. So actually, let's look at this because this is interesting. So remember that we talked about during the lecture that this group by here, the object that it creates, it's a tuple. So let's look at the first one. So you see here how we have one, which is the group label, and then we get this series. So if we wanted to do what I tried to do before that wasn't working, we need to apply a function here. So let's see, this is our data set. So this D here corresponds to the tuple. So for example, if we grab the first element of the tuple, you'll see we'll get one. All right. Well, these things happen. So let's see here. So let's grab the second one. Seems that it's creating a dictionary. Supplying, let's see here. Let's try this. There we go. So actually, so this D here corresponds to the second element of the tuple, not the labels. It corresponds to the data frame, the subset of the data frame. So if we take the mean of that across the columns, see we get a time series. So in order to get the mean for the entire month, we have to run another mean here. Well, so this would be a way to do what we were looking for before. And I believe, and let's try this thing out here, with a -1 it might give us everything directly. No. So in Xarray this would work, but here it doesn't. So we need to make sure that we have a double mean. Alright. So let's delete this. So let's aggregate the statistics. Well, this was an aggregate statistic, so what we're going to do is we're going to use a slightly easier function that gives us the monthly mean. So this is what we call resampling statistics. So let's take a look at the documentation. You see we resample time series data, and it's a convenience method for frequency conversion, just like we did before. So it takes a rule, a time delta or a string or a date offset. It tells us which axis to use for up and down sampling. And then there's some other arguments here that are used for specialized cases. But when we talk about a string for the rule, and this is what we primarily use, this string corresponds to the same arguments that we used in the date range. So remember when we used weekly, when we used monthly. So let's do the same thing here. So average t resample monthly. you see that we get a resampler object. And what that is, it's very similar to a group by object. So if we then call mean on those, we get the same answer as before. Well, here, for example, would have gotten the same answer. So let's do that so we can compare. And there we go. You see we get the same answer as before, but hopefully you'll agree with me that this is a much easier syntax and much easier to understand. Now, if we try to calculate the weekly minimum temperature, we just change the rule here. So we get the weekly resampler, and then we get the minimum temperature. And there we go. So again, this goes back to what we talked about pandas, trying to build these complex operations by chaining different calls to different functions. So here you see we have the resampling, then we call the function that we want to on the created objects. The other common estimation is the rolling window statistics. So we saw group by, we saw dot resample, the other one is rolling. And rolling will give us the moving, let's say average, moving, minimum, moving, maximum, because again, we create these intermediate objects based on this offset. And from that, we'll then be able to create the objects where we can calculate all kinds of aggregate statistics. So for example, if we wanted to take the 5-day average, remember that we have daily data, so by passing 5, we are getting the 5-day moving average. So, and to get the average, we get the mean. So you see here, the first 4 rows, they have nothing because there's no data beforehand. So then we have here we calculate the mean from these 5 days. So then the next day we'll have the mean of the previous 5 days and so forth. Now if you don't like this not a number here, there's another function, and again this goes to chaining. So we're gonna fill the fill in A, which actually gives us an error because we have to specify a method or a value. So if we pass value 0, you see that it puts zeros. The other thing I like to do sometimes is use a method backfill, which I think I spelled. Let's see. There we go. Sorry, typo here. But anyway, when we're backfilling, you see when we use the first value that we find that's valid when we're moving forward. We can also do forward fill. If we did that here, it's not going to work because there's no value beforehand to fill. So we backfill and we get the data that we need. Alright, so if we get the 10-day minimum temperature and plot it, so let's see, we get rolling 10-day minimum temperature, and then we're going to call plot. The nice thing that I wanted to show here is that by default, pandas will plot all the columns, will put different colors for each of them, put a legend with the column names, and then because of their time series, it will correctly format the x-axis. But more on that this coming week.